All right, today we are diving into one of the biggest and maybe most misunderstood technologies out there, machine learning. I mean, you hear this term everywhere, right? But what does it actually mean?
So, let's kick things off with a puzzle. And this goes back, believe it or not, over 60 years. It really gets to the core of what makes machine learning, well, so different. It's a question that totally flips the script on what we think programming is all about.
Way back in 1959, a pioneer named Arthur Samuel basically posed this incredible idea, the thought that a machine could actually learn to do something better than the person who programmed it. I mean, this wasn't just about a board game. This was the seed for a whole revolution in how we think about computers.
Okay, so to really get our heads around this, we've got to clear up the #1 point of confusion out there: AI versus machine learning. People use these terms interchangeably all the time, but here's the thing: they're not the same.
Here's the simplest way to think about it. Artificial intelligence, or AI, that's the whole big universe of trying to make machines smart. But machine learning, that's like a specific, really powerful star inside that universe. It's one of the main ways we actually achieve that intelligence.
So let's look at two totally different ways of being smart. On one side, you've got your classic rules-based AI. Think of a simple thermostat. A human has to sit down and write every single rule. If the temperature is below 67, then turn on the heat. The logic is all hard-coded, right? But then, look at the other side, machine learning. The perfect example is your spam filter. No one tells it if an email contains this word, it's spam. Instead, you just show it thousands and thousands of emails, and it figures out the patterns for itself. It learns implicitly. And honestly, that right there, that's the whole game changer.
Okay, so how does this whole learning thing actually work? Like, what's going on under the hood? How do we get from a pile of data to a machine that can actually make a decision? Well, instead of those hard-coded rules, a machine learning model is basically all about math. It uses a special algorithm to hunt for patterns in data. Let's make this super concrete. Imagine we're trying to build a simple model to predict how much a house is worth.
And this is where the magic happens. It's called the training loop, and it's the absolute heart of the process. So first, you feed it a bunch of data about houses. Then the model makes a guess. And this is the key part. It immediately checks to see how wrong it was. It measures its own error. Then it tweaks its internal math just a little bit to make a better guess next time. And it does this again and again and again. We're talking thousands, sometimes millions of times. With every single loop, it gets just a tiny bit smarter.
But here's the most important part of all. The goal is not for the model to just memorize the house prices it's already seen. That's like just memorizing the answers for a test. The real goal is something we call generalization. Can it look at a brand new house it's never seen before and still make a good prediction? When it can do that, that's when you know it's actually learned the underlying patterns, not just the answers on the cheat sheet.
All right, so it turns out there's not just one way to teach a machine. There are actually three main approaches, or you could think of them as different teaching styles.
And each of these is really good for different kinds of problems.
Okay, let's break these down. First, you have supervised learning. The analogy here is perfect. It's like learning with an answer key. You give the machine data that's already labeled with the correct answer. Next, there's unsupervised learning. This time, there are no labels. You just dump a bunch of data on it, and its job is to find hidden patterns on its own. Kind of like telling it to sort a huge, messy pile of photos. And finally, you've got reinforcement learning. This is learning from pure trial and error. Think about an AI learning to play a video game. It gets points for good moves, loses points for bad ones, and just keeps trying until it masters the game.
Okay, but what happens when the problem is way more complex than just predicting a house price? What if we want a machine to recognize a specific face in a massive crowd? Or, understand a sentence with all its nuance?
Well, this is where things get really interesting. What if instead of just one single algorithm, you had millions of them, all arranged in layers? That is the fundamental idea behind deep learning, and it's the engine that's driving almost all of the crazy AI advancements we see today.
So deep learning uses something called artificial neural networks. And yeah, they are loosely inspired by the way our own brains are structured. All those layers let them learn patterns that are just unbelievably complex and subtle. The kind of stuff that older ML models just couldn't touch. Now, the trade-off is that it needs a ton of data and some serious computer power. But this layered approach is exactly why we now have things like large language models and all the crazy generative AI stuff.
Okay, so why should you care about all this? Well, because whether you've noticed it or not, machine learning is already everywhere. It's totally woven into your daily life.
Let's talk computer vision. That moment you unlock your phone with your face? Yep, that's machine learning. It's literally giving machines the ability to see and understand the world through images and video. It's the tech that lets self-driving cars see the road.
Or how about natural language processing? Anytime you talk to an AI assistant or use a translation app, you're using NLP. It's the entire branch of machine learning that's focused on teaching computers how to understand and speak our languages.
And you know those recommendations from Netflix or Spotify that are just weirdly perfect? That's a recommendation engine. A lot of the time, it's using unsupervised learning to find those hidden patterns in what you like, compare it to millions of other people, and figure out exactly what you'll probably love next.
So that brings us to a final, pretty big thought. I mean, think about it. We went from teaching a computer how to play checkers to teaching it how to see, how to talk, and even how to predict what we want. All of this is being learned from the massive ocean of data we all create. And it makes you wonder, right? As these machines get more and more capable, what should we be teaching them next?